Sample space. Shh. Sample space is the set of all possible outcomes. Please stop the talking. The set of all possible outcomes. What are some examples of situations we know possible outcomes? A coin toss. It's either what or what? Heads or tails. You roll a die. A 6-sided die, it's going to be either what? 1, 2, 3, 4, 5, 6. Not yet. Not yet. We will. All right. A letter grade. What's the highest letter grade you can have? A. Second.
C.
Third.
C.
Fourth.
C.
And the lowest? F.
Can't you get an I?
Yeah, mine's used.
You don't go to school or something like that, incomplete?
What? It's not. That doesn't stay with you though. Shh. What was that?
Mine's already in the.
We're not going to discuss it today. All right. Shh. Guys, please stop. All right. An outcome, an event is the next word. An event is an outcome or set of outcomes. Shh. All right, so a sample space is a set of all possible outcomes. The event is you actually did something and what was the outcome. Okay, if we flip a coin 3 times, what are the possible outcomes? And you make a tree diagram. Okay, do you guys agree on the very first flip, it's either heads or tails? If you flipped a heads first, does that have any impact on your second flip? No. Do you agree? Once I flip a head, it's not more likely to get a head again. It's either heads or tails. Still 50-50, yes or no? Same thing is true if I flipped a tails first. The second flip is still equally likely, heads or tails. Do you agree?
Yes.
Okay, the third one. If I went heads, heads, I could go heads, tails. If I went heads, tails, I could still go heads, tails. Do you see that? If I flip tails, heads, I then have the choice of, or not choice, possibility of heads or tails. Tails, tails, heads, or tails, tails, tails.
Heads, tails.
All right. How many possible outcomes? How many possible outcomes?
2.
1. It's 8. Heads, heads, heads. Heads, heads, tails. Heads, tails, heads. Heads, tails, tails. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible outcomes. Got it? All right. What is the sample space? Sample space is an outcome or set of outcomes. What is the sample space for the event of flipping a coin 3 times and observing the number of heads? Okay. Can you flip the coin 3 times and never get a heads?
Yes.
Is it possible to get tails, tails, tails?
Yes.
Okay, so what would I say would be my first number would be a 0. It is possible to get 0 heads. Is it possible to flip and get only 1 heads? Yes, right here. Heads, tails, tails. Tails, heads, tails. It happens more than once, but it's only one. There is a possibility for to get 1 heads. Is it possible to flip a coin 3 times and get 2 heads?
Yeah.
Heads, heads, tails. Or tails, heads, heads. Make sense? Okay. Is it possible to flip a coin 3 times and all 3 of them be heads?
Yeah.
Heads, heads, heads. Do you see that? So that is 0, 1, 2, 3. No heads, 1 head, 2 heads, or 3 heads. Questions? All right, we're going to skip this piece right for now. We're going to go to Venn diagram. We'll come back to this later on, another time. Actually, I do want to focus on this one first. If you roll 2 regular 6-sided dice and record the sum, what is the smallest number on a die?
6.
The smallest. 1. What's the largest? So if I roll 2 dice and I get 2 ones, that's the smallest possibility. What's the smallest sum I could have? 2. Do you see where that 2 is coming from? Do you agree it's not possible to have a sum of 0 or 1 if I'm rolling 2 dice?
Yeah.
Gentlemen, I need you guys listening. Okay, is it possible to roll a 3 for a sum? Can you give me some numbers that would be a 3? 2 and a 1 or a 1 and a 2? Is it possible to get a 4?
Yeah.
What are some possible numbers? 2 and 2 or 3 and 1 or 1 and 3? Okay, is it possible to get an 8? Give me some numbers. 4 and 4. Any others? 5 and 3. 6 and 2. What about 7 and 1?
Oh, no, there's no one.
There's a 1, but there's no 7. All right. Is it possible to get a 12? 6 and 6? Yes? All right, questions. Okay. Venn diagrams. Diagram using shapes, circles to show the relationship between two or more sets of data. All right. I'm going to tell you that in a classroom there are 22 males and 20 females. Now, there's no overlap, so you're either one of the 22 males or one of the 20 females. I know. All right. Shush. We're not going to discuss that today, guys.
I mean, Cody kind of goes both
Okay. You guys, enough.
I do, actually.
Enough. Oh my goodness, guys.
Did you just assume his gender? Yeah, you can't do that to me this way.
All right. Next one. In a sample of 100 A students, 60 have an A in math. Period.
A sample of what? Of 100? Doris?
In a sample of 100 students, sorry. Oh no, yeah, I had it right. 100 A students. 60, yes.
Straight A students?
No, just have at least one A. You have at least one A, you're considered an A student. In a sample of 100 A students, and I'm going to change that 60 to 65.
Oh.
If you guys will do that with me now. In a sample of 100 A students, 65 have an A in math. Now, it's just an A period. So is it possible that a kid has an A in math and English?
Yes.
Is it possible that a kid has an A in only math?
Yep.
Or only English? What does this region right here represent? The A's in both. All right. We're going to continue. 65 have an A in math, comma, 20 have an A in math and English. Period. How many? Yes. How many have an A in only English? Shh. All right. Yes. In a sample of 100 A students, 65 have an A in math, 20 have an A in math and English. How many have an A in only English?
Why don't you do any work on the board?
Huh?
Why don't you do any work on the board?
I don't want to. All right, guys, we're listening. Okay, what did you say the answer is? 15. Anyone else?
15.
Okay. Listen before we get too far. The part you will always fill in first is the overlap. You'll always do the overlap piece first and then work your way outward from there. All right, how many kids have an A in both math and English? 20. So we're going to start there.
5.
Now, a mistake kids make is they put the 20 there and then they say, oh, this is 65. That's not true. Because if I put the 65 there and I cover this means how many people have an A in math? 85, and that's not what was given. So how do you figure out the number? How many have an A in math altogether?
Subtract the 65 from 20.
There you go. You are correct. You subtract 65 minus 20, and what does that give you?
45.
40, 45. All right. Questions so far? All right. How many kids are there altogether in this sample space?
100.
100. Do you agree? All right. 45 plus 20 is what?
65.
65. How many are left over? What's 100 minus 65? What is it? 35. All right.
Okay, that's better. I was like, wait, whoa, how did
Okay.
she get 35? And I realized, oh, she didn't give a number for how many.
Right,
only names.
right. Okay, so how many have an A in only English? 35. All right, so listening here. I'm going to cover this. Actually, I'm going to leave it here. How many have an A in both classes? How many have an A in math? 65?
45.
Yes, just an A in math.
I'll be fast.
I didn't say an A in only math, just an A in math. How many have an A in English? 55? How many have an A in only math? How many have an A in only English? All right, do you understand how to read the information? All right, we're flipping over to the back side. 25 students. This one, my other class said it was a little confusing, so I want to make sure everyone's paying attention. Okay, we have an aquatics program. Some are swimmers, some are water polo players. 25 students are on the swim team. 14 of those swimmers play water polo as well. 5 only play water polo. Where did we say we work first? The middle. How many do swim and water polo?
19. Oh, wait.
It's right here. 14 of the swimmers also play water polo. So 14 do both. Do you agree?
Yeah.
All right. How many swimmers were there? So do I put a 25 here? No, we do 25 take away what? 14. And what does that give us? 11. All right. So how many swimmers are there altogether? 11 plus 14 is? And is that what was given to us? Of those 25 swimmers, how many only swim?
11.
And how many swim and do water polo? 14. All right. 5 only play water polo. Do I have to subtract or did they give me the actual number? So what goes here? 5. All right. How many water polo players? 14, 5, or do I add something together? 19. And how did you guys get that? 14 plus 5.
And then 30.
How many students participate in an aquatics program?
30.
We do 11 plus 14 plus 5.
It gives you 25.
11? Right, because 25 plus the 5 that only did water polo. Or you can do 11 plus 14, which is 25, plus the 5 equals 30. Questions? Does it at least make sense? All right, next one. 40 students served attention yesterday. 25 worked on math. 18 worked on English. And 11 worked on both. How many worked on neither? So in this possibility, we have some kids that didn't work on math or English. They worked on their science or they worked on their foreign language. All right, let's fill in. Do we have any overlap? 25 worked on math, 18 worked on English, and 11 worked on both. So what goes in the middle? 11. How many worked in math altogether? So what do I do? 25 take away,
11.
and what does that give you? What is it? 14. All right, 18 worked on English. That's all this here is 18. So what do I do?
Subtract 18.
18 minus 11, and what do we get? 7. All right. How many worked on neither? Everything that's in the bubble, are those kids that worked on neither, or everything in the bubble is a kid that worked on math and or English? Do you agree everyone in this bubble worked on one or both of them? How many kids are there in this bubble altogether? Can you guys do that? 14 plus 11?
32.
14, he's right. 14 plus...
Oh, I thought you were talking about both bubbles combined.
Okay. 14 plus 11 plus 7 is what? And it gives us the steps. Step 1, complete the Venn diagram. Did I do that already? Yes? Step 2, count the total number of students represented in the diagram. 14 plus 11 plus 7 is 32. Yes or no? Step 3, subtract from the total of 40. Does that make sense? If there's 40 kids and 32 of them worked on one or the other, how many worked on none of it? Neither. 8. And the 8 goes in here like this. It's part of the box, but it's not part of the kids who worked on math or English. Does that make sense? So it's part of the sample space, but it's not part of the events of math or English. Questions on how we got that or how to set up your diagram?
That's pretty easy.
Pretty easy? All right, next one. Two-way table. Please stop. Two-way table. And a sample of 40 students. 15 males went on a summer vacation. Okay, we have male, female, vacation, stayed home. And 10 stayed home. We're talking about the males. So what should I put here for male vacation?
15.
For male home. Do you guys see where he got 15 and 10 from?
Yes.
Total 15 plus 10 is what? 25. All right. Females. Of the females, 9 went on a summer vacation and 6 stayed home. What do I put here for female vacation? And for female stayed home? 9 plus 6 is?
15.
All right. And total this way. What's 15 plus 9?
24.
24. What's 10 plus 6?
16.
Can you guys do 24 plus 16? 40. And does that give us the 40 students? Can you guys do 25 plus 15? Is it also 40? Should it work out 40 either way? Yes.
And is that the way you check it to see if you got it right?
That is correct. All right.
Put 50.
Oh, sorry.
You made it.
All right. Questions? Okay, you guys have done the Venn diagrams and these charts before, yes? All right, I'm going to have you do the best you can to fill in the last one. 100 freshmen and sophomores were surveyed about whether they are involved in a co-curricular activity. Partial results are in the two-way table below. Complete the table. Use your calculators, do it by hand, in your head. I want you filling them in. Do that now. Anybody have at least one of the numbers?
45.
For what?
The total on
All right.
the freshman.
Can you tell us how you got that?
I just did 100 minus 55.
Okay, 100 minus 55 is 45. All right, keep working. Anyone have another number? Yes.
People who have no elective.
Freshman with no elective. Can you give me that? Can you tell me how you got it?
So subtract 45 and 28.
Okay, 45 minus 28 gives you 17, and Cody said 100 minus 55 gave him the 45. All right, anyone else? Another number?
There's the total for the freshmen and sophomores that said no.
These right here?
Yes.
Okay, add them up and we get
31.
31. 17 plus 14 is 31. Anyone else? Another number? Yes. Sophomores right here is what? 31? 41? It's okay. Can you tell us how you got it? Good. 55 take away 14.
Can we do this like last year?
Yes. I don't know when it was, but you have.
Just common sense.
Okay, it is. And then total 28 plus 41 is And then 69 plus 31, is it 100? And 45 plus 55, is that 100? All right. All right, questions on any piece here?